The homework that you did Friday was to name these compounds. You got two different names. No matter which name you are using, you're going to have to find the oxidation number of your cation. So, we'll start with the anion. You know, oxide always has a -2 charge. So 2 times -2 gives you an overall -4. So that means this overall would have to be a +4 to equal 0. I've got one of these, so 1 times whatever this mystery oxidation number is will give us +4. So 1 times +4 gives us a +4. So your IUPAC name is manganese 4 with the Roman numeral. Remember, the Roman numeral is the charge. Oxide, O-X-I-D-E. Now, the traditional name, you have to know that manganese can be either a +2 or a +4 charge. Well, this is +4, so it is the higher charge. The higher charge would give it the IC suffix, so we would say manganic oxide. Over here, we're going to do the same thing. We do not know the oxidation number of lead, because you could have lead 2 or lead 4. So we have to look at our anion. In this case, our anion is chlorate, and it has a -1 charge. Well, we have 4 of them, so 4 times -1 gives us an overall -4 charge. So in order to equal out to 0, because it is a neutral compound, this has to be a +4 charge. We have one of these, so 1 times whatever this oxidation number is has to equal +4. So 1 times +4 will give us a +4. That means that the IUPAC name is going to be lead 4 chlorate. Now, the traditional name, again, we have the higher charge because it's +4, so it would be plum bic chlorate. In this case, we've got PBS. Sulfur right here is monatomic. The monatomic sulfide ion is going to have a -2 charge. We find that on the periodic table. It's directly underneath oxygen. We have one of these. 1 times -2 gives an overall -2 charge. So in order to equal out to 0, this would have to be a +2. We have one of these, so 1 times +2 will give us our +2. So the IUPAC name is lead 2 sulfide with an IDE. This is the lower oxidation number, so we would say plumbus sulfide. Gold, also multivalent. We don't know what the oxidation number is here, so we look at our anion. This is the nitrate anion, which has a -1 charge. Again, make sure you put that circle around your polyatomic ion so that you don't get to thinking that you have to do anything with that 3. You do not have to. You have one nitrate anion there. 1 times -1 gives you a -1. So your overall has to be a +1. We have one gold here, so this would have to be a +1 charge. So we would say the IUPAC name, gold 1 nitrate. This is the lower oxidation number, so we would say RS nitrate. Alright, let's see what we've got here. In this case, we've got oxygen as our monatomic anion. Oxygen as a monatomic anion will always have a -2 charge. We have one of them, so this is a -2. This has to be a +2. In this case, we've got 2 gold cations, so we'd have to say 2 times a +1 charge would give us a +2. So this also will be called gold 1 oxide, or RS oxide. This one, I'm going to put a circle around this phosphate polyatomic so that I don't think I have to do anything with the 4. Remember, phosphate, PO4, has a -3 charge. I have one of these. So 1 times -3 gives me a -3. This has to be a +3. I've got one of these. So 1 times a +3 will give me the +3 I'm looking for. So this one is gold 3 phosphate. This is going to be my higher oxidation number, so I would say auric phosphate.